Hi, today we're gonna talk about certification authority using the Oracle service to create certificates. So, the objectives of this video is to create a certification authority to emit private certifications. We're gonna add an intermediate certification authority. We create a root certification authority and the intermediate one. We will create a certificate and we'll import the certificate into machines so we can trust the root of the certification. So, first we're gonna talk about the Oracle Cloud Certification Servers. You can find about the Oracle Cloud Certification Service in the Identity and Security. You're gonna find certificates. You can see our review. Here we have resources that we create. First, you have to create a root certification authority and create a subordinate certificate authority. And then you can create a certificate. Or you can import the existing certificate to manage in the server. So let's see the certification authorities we have here. I have created a root certification authority and a subordinate certification. You can create one here. So selecting root certificate and giving a name. The name could be anything. It's not part of the certification. Then you put the common name. This will be part of the certification authority. Let's see, company name. And then we can add a country. Say we are in United States, USA, United States, and you can provide your state or province, the street, the organization unit. This is all optional, but you can provide here. Then you go next, and you select the validation. The default validation is 10 years. Recommend you stick with that. And then you have to create a key. So you have to create a key in the key manager to assign the certification. The key you create here in the Identity and Security. Let's see again. Identity Security, you go to Vault. You create a vault. If it doesn't exist, you can have only one vault if you want. But here in the vault, you create a key. You give it a name. It has to be ASM protection mode, which is protected by hardware. It can be protected by software. The protected by software keys are free, and protected by hardware you have 20 keys for free for each key you generate. So if you generate a symmetric key, it's just one key. If you generate a RSA key for a symmetric encryption, decryption, sign and verify, it will generate 2 keys, so it will count 2 in the free tile. And if you pass the 20 keys for free, you pay a little bit for each key. Let's check OCI key cost. So the software protected keys are free, and the ESCM protector keys are $0.53 per key version per month. So each key will be $0.50. So for the encryption of certificates, you have to generate a SJ key. And you select one of the length. I think 2000 bits it's enough. And you gave it a name. And after you select the create the key, you can use them here. You select the singing algorithm. I recommend you use your SSDA 384 because it doesn't have one, it's more secure, and it doesn't have a possible length attack, which SSH 512 has. So I recommend the 384, but you can select anyone if you want. After you select the singing algorithm, you gave in a maximum valid rate of certificates. 90 days is good, and a maximum valid duration for the subordinate certificate, which 3065 days. It's I don't know, 60. I think it's 5 years. No, it's 10 years. So it's 10 years, and you provide a revocation configuration. It will use an object bucket storage. Pay attention that if you create one CA, you can't share the object storage between the CAs created, between the certification authority, and you provide an object format list. Could have CA slash revocation list, and you provide the brackets, so the version of the revocation list will be added to the bracket. The custom format URL, you can make it blank, and then you go next, and then gonna be summary for you, and you can create your root certification authority. I won't create one here. After you just create a subordinate certification. You can go to the root certification you create, and then you can go to subordinate certification and create a subordinate certification authority. It will have the same information we just created before. It can use the same key to assign. I don't think you need another key. At least the Oracle console lets you choose the same key. So after you create the subordinate certificates, you can create a certificate. Now there is two ways to remit a certificate. One is issued by internal CA. This means you're gonna use the certificate internally in the load balance, for example, or you can use in other Oracle servers, or you can use issued by internal but manage the external. That means you will be creating the certification keys and the certification requests outside the Oracle Cloud. I recommend you use that if you want to use external servers, or if you want to emit for a VM, or for servers that is not managed by Oracle. So we're gonna select the second. I'm gonna use the name. I'm gonna put the name here, test. So after that, select the valid. I recommend you put, if you don't want to manage too much the certificate and you trust your network, you can put 1 year. For instance, I can put December 23. It's October 23. And certificate signing request, you can upload a file or pass the content here. So we talk about this KM keys, the root CA, the intermediate certificate. Please just use the intermediate certificate to generate the certificate. Don't use the root certificate to generate certification. We will talk about create certification signing request. So to create a certification signing request, you can use OpenSSL. In this case, I'll create one key, one private key. I'm gonna create the request in that file con Kubernetes vault kubernetes.com CSR, and I use a config answer. If you don't want to answer, the request is gonna ask you some questions. If you don't want to answer those questions every time, you can use our answer file. The answer file, if you see here, and you can use the default bits, the default hash, which SHA to 256, and the extensions for the certificate, the request, the distinguished name is the N. So the country, the state, the location, the organization unit, and the common name that you're requesting. And you can use the subject auto name, which is the DNS names that this request is gonna answer. So in this case, an answer for 4 DNS names. And then you can just run this command using the config file. First you need to generate the key. And to generate the key, you can use the new key if you want. Instead of, if you already have a key, you can use the key parameter. If you want a new key, you can use the new key. If you don't want a passphrase, just none. I think you need to provide a key out. Need to provide the nodes. Okay, you generate answer request. So just use that command, create a new key, providing the key out to the file, and use out of the request to the file, and you using the config answer file. So you can upload or you can pass the content. So that's the request. Just put next, and it will provide a summary, and you just create a certificate. After you create the certificate, you can see the state, and you can see the certificates using the view content. Now you can renew the certificate, so it has a version number. It will increment the version number, and you renew the certificate and emit a new one. So you can view the content. This is the certificate, and this is the certificate chain. We need to download the two. After you download, you have two files. One is the certificate, which is a pen file. The other is the certificate chain, which I have renamed to Kubernetes servers.pen. So after that, you have a certificate. Now we have the certificate. Now we need to add the intermediate certificate or the certificate chain to the machine, so we can trust the certification we just emit. For do that, in the Windows machine, we need to convert the file from the pen file to the CAT file. And to do that, use that command, and you get the pen file in the sheet HX 509 format, and you output it in CAT file format. So So after you output the file, you can just double click the file, which is just created. The file you just created, you can double click, open, you go to install certificate, and you can go to the local machine, You place the certificate in the follow store, select your browser, and you select the trusted root certification authorities. You can select the intermediate certificate authorities as well, because you're using the intermediate certification, not the root certification. It doesn't matter, it works. So after you do that, I already done that, you should see the certificate as trusted when you open it. In the Linux machine, if you're using Ubuntu, you copy the file to the USL local certification, share certificates, and you need to use sudo to do that, and you update the cert store using this command, sudo update cr certification. If you're using CentOS or if you're using CentOS 6, you need to use the update cr trust as well. You add to a different folder, pk cr trust source anchors, and use that command using update cr trust extract. Now if you're using Arch Linux, as I am, you need to use trust anchor and pass as a store the CRT. You need to convert the file as well from pen to CRT, and that's it. You just run this command and it will be done. Now inside Kubernetes, when you install the certificate on your server, you also have to do some things to trust the root certification authority, because the container will not get their CR root from the host server. And unfortunately, if you add the CR root in the host server, it will not be automatically available for the containers in the Kubernetes cluster. So you have to add in all the containers that are calling the code for the server. And that's it. We create the certificate, and we are using then in the server. Please follow the documentation for your server in order to install the certificate and the certificate key. For instance, if you're using Apache, there is documentation on how to do that. In this case, I'm using Vault server. We're gonna talk in the next video, so we will see how to use the certificate. It's just 2 lines of configuration files. Is very easy to do so. So thank you for watching.